All right, Math 2, here we go. We got our second lesson about factoring. This is lesson 4.1.2, factoring with area models. All right, so we're going to look at factoring something called a trinomial. Trinomial is when we have three terms. So when we have three terms in our polynomial, this type of factoring usually will produce a binomial, that's two terms, times another binomial. All right, and so last time, we were looking at a pattern that we found in the diagonals. But let's finish up this area model real fast. So as a sum, we can see that this would be 10x squared. We have like terms right here. That makes negative 39x. And then plus 14. So that's written as a sum. Now we're going to write it as a product. So let's see, since this is 535, I'm going to call this one 5x, and I'm going to call this one 2x. Okay, because 2x times 5x is 10x squared. Why did I choose 5x for this one? Because this was 35 up there. So I now know this could be negative 7. So 5x times negative 7 is negative 35x. And then 2x times something equals negative 4x. So this must be negative 2 right here. And then negative 7 times negative 2 does equal negative 14. So it's all working out. All right, so as a product, this is 2x minus 7 and 5x minus 2. This is factoring. Starting off with the sum and getting a product is the process of factoring. We're basically undoing the area model. We're undoing the distributive property. So starting off here and getting to these two products here, that is called factoring. Turning a trinomial in this case into two binomials being multiplied. This is called factoring. All right, does the pattern for the diagonals found in the last lesson work? So the pattern for the diagonals that we found is if we multiply the diagonals, they equal each other. And in this case, let's see. When I take 10x squared times 14, I get 140x squared. When I look at this red diagonal here, negative 4 times 35, that is 140. And then x times x is x squared. So yes, the pattern still works that we saw the other day. All right, so now what we're going to do is we're going to create an area model for the polynomial sum 2x squared plus 5x plus 3. All right, so just a second, let me get my stuff here. I had to pause. I forgot my algebra tiles. This one, I wrote down the problem wrong. This should be plus 2 at the end there. So we're going to change that real quick. So I've got 2x squareds. There's 2 of them. I got 5 of the x ones. There's those. And I've got 2. Now I'm trying to turn these into an area model. And here's the problem that I kind of am going to run into here. So if I did an area model, I know from past experience that like the 2x squared, like on the previous problem, was down there. The positive 2 was over here. But then this 5x right here, that was made from combining my like terms, because remember over here I had negative 35x and negative 4x. So that's where I was getting the negative 39x. So that middle term is really the tricky term because I'm missing, I don't know the combinations there for that one. But if I take out an area model, I can kind of see what might work with this. I can set it up like this. When I have my algebra tiles, now I can see it's working here. So it looks like this side here is 2x plus 1, and this side is x plus 2. And so it should work like that. Okay, so it looks like after doing that with my area model, or my algebra tiles, I always mix up the names. So this was an x squared here. This was an x squared here. We had an x over here. And then we had 2 of the x's there. And we had 2 of the x's right here. And then we had 2 singles right here, 2 single ones. So this side was x and 1, and this is x, 1, and 1. So we saw that when we did that, we had x plus 2 and 2x plus 1 setting up that. So looking at that, I can see here that multiplying these two together, 2 times 2x would give me 4x. And multiplying these two, x times 1 would give me just 1x. So it looks like those 5 x's were split between 4x and x. So here I've got 2x and plus 1. So that's where I'm getting this from right here. And then this side we said was x plus 2. And yeah, it's still working, x plus 2. So what we're seeing here is the really difficult part is finding out how to split up this 5x that's sitting here in the middle. All right. So factor 3x squared plus 10x plus 8 using the area model. All right, so now I've got to split up 10x somehow so that it's going to end up working. So 10x has to split up between these two. Now we can pull out our area models here, or we can also look at how our numbers are being formed here. So here, these two numbers are being multiplied, and then these two numbers are being multiplied to give me these. So it looks like I'm multiplying and then adding them together to get that middle term right there. So I'm multiplying and I'm adding them together. So I got an option here. I can just start guessing. I can really just start guessing and go, okay, 10, can this be 8 and 2 to make 10x? So 8x and 2x? Or can it be 5x and 5x and make that work? I can just start plugging in numbers, or I can think back to our pattern here. We notice that the diagonals are always, when you multiply them, they're equal to each other. Okay, so that's one thing that I noticed. So I noticed here that when I take these two diagonals and I multiply them, I should get the same multiplication going the other way. So if I multiply 3x squared times 8, I get 24x squared. All right, so 3x squared times 8, 24x squared. That means these two, when I multiply them, according to this pattern up here, they should also be 24x squared. Okay, well, that's kind of helpful. So what else is helpful? Well, the other thing is I know that those two numbers right here also have to add up to 10x, because when we combine our like terms, that's how we're getting this number here. We combine them, we add them together, 4x and x, that's 5x. So this means that these two numbers have to add up to 10x. And remember all those diamond problems we've been doing forever on our homework? Now we know why we've been doing them. Is because they're going to help us with factoring. So what number multiplies to give us 24 and adds to give us 10? So what you can do is you can break up all the factors of 24 if you want to. So that'd be like 1 and 24, 2 and 12, 3 and 8, 4 and 6. So these are all of our different ways. So do any of these add up to 10? Yes, 4 and 6 do. So this must be 4x and 6x. So those are our two factors that we can plug in over here. So 4x can go here, 6x can go here. It doesn't matter which order you place them in. You could have done the 6x there and the 4x there. It doesn't matter. So these multiply to give me 24x squared because these two multiply to give me 24x squared. And then they also add to give me this 10x in the middle. So that's the pattern that we're seeing here. So now I can finish factoring it. So it looks like this one should be x and this should be 3x. And then x times something equals 4x, so this must be plus 4 right there. And then 3x times something equals 6x, so this must be 2. It says 3x times 2 is 6x. And then 4 times 2 is 8, yes. So now if we factor it, remember factoring is writing it as a product. So 3x plus 4 and x plus 2. We have now factored our first problem. All right, so what two things do we know about the missing squares? These two missing squares. The two things that we knew were, number one, they multiplied to be equal to the other diagonal. So they multiplied to equal the other diagonal multiplied, the product of the other diagonal. And then we also knew that on those other ones, that they added to the middle term. So these two added to the 10x, or their sum was the middle term. So that's probably a better way to write it, but I've already written added. So they added up to the middle term. All right, so if we're doing 2x squared plus 7x plus 6, I've got 2x squared and 6 here. When I multiply those two together, 2x squared times 6, that is 12x squared. Now, these two numbers should multiply to give us 12x squared because the diagonals, when you multiply them, they equal to each other. The second thing that I know is they added up to the middle term, so they should add up to 7x. So what numbers multiply to give us 12x squared but add to give us 7x? We don't have a lot of choices for this one. We've got 1 and 12, we've got 2 and 6, we've got 3 and 4. I think I found it. It's 3 and 4. So this is 3x and 4x. They multiply to give us 12x squared. They add to give us 7x. So this part right here would be 3x. I could put the 4x there if I wanted to. It doesn't matter which order you do it in. And that one would be 4x because they multiply to be equal to these two and they add to give us this middle term in the middle there. So this would have to be x. This would have to be 2x. X times 3 equals 3x. And 2x times 2 equals 4x. And 3 times 2 does equal 6. So I can tell that I did that right. So I can tell that my factors are 2x plus 3 and x plus 2. And I have now factored 2x squared plus 7x plus 6. All right, so now we're going to start just from a blank problem. Okay, so the first thing that I would do is set up an area model. In the area model, I know that the 6x squared would probably go like right here, and the 12 would go here. The hard part is figuring out what these two values are. But I know something about those two values. I know these two values have to add up to 17x. So they're going to add to 17x. I also know that they're going to multiply to be equal to 6x squared and 12. So that should give me 72x squared. So I need a number that multiplies to give me 72 but adds to give me 17. You might have already thought of it. We could do 1 and 72, 2 and 36, 3 and 24. Oh, this is going to get hard. 4 and 4 goes into there with 18. 5 doesn't go in there. 6 and 12. And finally, 7 doesn't go in there. 8 and 9. I found it finally. 8 and 9. Why is it always the last one you look at for? It's kind of like when you're looking for your keys. It's always the last place you look. Anyways, this is 8x and 9x. Has to be, because that's the only two numbers that add to give me 17x, because they have to add to the middle term, and they multiply to give me 72x squared, which is the same as this diagonal squared. So this must be 8x and 9x. So now we can finish the factoring process. So I know this is going to be 3x and 2x. That's the only ones that really they're going to fit in this one. And then 2x times 4 is the 8x. And then 3x times 3 is the 9x. And then 4 times 3 is 12. So it's all working. So after all that work, I can now confidently say that 3x plus 4 times 2x plus 3 is what this factors into. There we go. We have factored it. All right, I think that's it. Yeah, that's it. That's our lesson. All right, we'll do some more factoring next time. Math hard. See you later. Bye-bye.